I have deeply analyzed and researched the sources and read the reference script thoroughly. I studied its structural rhythm, a bold opening claim, the macro market data that backs it up, the paradigm shift driving it, the specific hardware proving it's real, the philosophical stakes, a grounded, honest close about the timeline, its habit of pairing hard numbers with plain language explanations, its rhetorical repetition for emphasis, and its confident, slightly urgent, "this is bigger than you think" tone without tipping into pure hype. I also ran fresh research across multiple current sources, including IDC's own revised market forecasts, Tom's Hardware and Gadget, PC World, CNBC, and NVIDIA's own newsroom, to make sure this script reflects where the industry actually stands as of late July 2026, not where it stood when the memory crisis first started making headlines. The computer sitting on your desk right now is already behind, not because it's slow, not because it's a couple of years old, but because the entire definition of what a home computer is supposed to do is being rewritten in real time in 2026, and most people haven't noticed yet. We're at the most significant inflection point in personal computing since the PC itself was invented. This isn't a faster chip or a slightly better laptop generation. It's a fundamental change in the relationship between you and the machine on your desk. And the data backing that up isn't speculation. It's already showing up in market forecasts, hardware launches, and quarterly earnings calls happening right now. So here's the real question I want to answer in this video. Is your next computer even going to look like a computer? Stick around, because by the end you'll understand exactly what's driving this shift, what hardware is already shipping because of it, and roughly how much time you actually have before this becomes unavoidable. And if this kind of what's actually changing in tech breakdown is useful to you, consider subscribing, because we track exactly this kind of shift as it happens, not months after the fact. Let's start with a number that should immediately catch your attention. The global PC market is in trouble, but not for the reason you'd expect. According to IDC, one of the most respected technology research firms in the world, the PC market isn't struggling because people want fewer computers. As of IDC's most recent 2026 revision published in March, global PC shipments are now projected to fall by roughly 11.3% compared to 2025, a sharp downgrade from the 2.4% decline IDC had forecast just months earlier, back in November 2025. In real numbers, that's a drop from around 284.7 million units in 2025 to roughly 252.5 million units in 2026. And despite that steep drop in units sold, IDC actually expects the total market value to rise slightly to somewhere around $274 billion, because average prices are climbing at the same time volume is falling. Why would prices go up while sales go down? Because of a global memory shortage that started accelerating in mid-October 2025 and has only intensified since. AI data centers need enormous amounts of high bandwidth memory to train and run their models, and memory manufacturers have been redirecting production away from consumer devices, phones, laptops, desktops, and toward the chips that power AI infrastructure instead. IDC has warned that PC prices could rise by as much as 6 to 8% in 2026 as a direct result, and the firm's research manager, Jitesh Ubrani, said plainly that the era of bargain-priced PCs and tablets is behind us for now, adding that memory shortages are expected to persist well into 2027, with pricing unlikely to return to 2025 levels even after supply eases. Here's the paradox sitting at the center of all of this. Computing technology is advancing faster than at any point in its history, but the physical components needed to build it are becoming scarcer and more expensive at exactly the same time. The collision is not a coincidence. It's a direct consequence of the same underlying force. The machines people have been buying for the past decade were built around one simple assumption that a user opens an app, does something, and closes it. That model is ending, and the companies designing the chips inside your next computer already know it. This is what the industry is now calling agentic AI, and it's the single biggest force reshaping home computing heading into 2027. An AI agent isn't a chatbot. It isn't a voice assistant that sets a timer or reads you the weather. An agent is a system with a goal, the ability to take actions on its own, monitor the outcome, and adjust without you sitting there directing every step. An agent can manage your calendar, draft and send routine emails in your writing style, track your spending patterns, coordinate with other devices in your home, and quietly handle dozens of small decisions that currently eat up your day, all while you're doing something completely unrelated. The agent isn't waiting for input, it's already working. And the hardware built specifically to run these agents locally inside your own home without sending your personal data to a remote server is arriving right now, not in some distant future roadmap. At Computex 2026 in Taipei, held at the start of June, NVIDIA and Taiwan's MediaTek jointly unveiled a new chip called RTX Spark. NVIDIA CEO Jensen Huang described it on stage as a reinvention of the personal computer, comparing its significance to the shift from feature phones to smartphones. According to NVIDIA's own announcement, RTX Spark delivers roughly 1 petaflop of AI performance, up to 128 gigabytes of unified memory, and the ability to run agent models with up to 120 billion parameters locally, on device, using up to 1 million tokens of context, all without a cloud subscription and without your data ever leaving the machine. Huang's own words on stage were direct. For 40 years, you launched apps. Click, type. With RTX Spark and Microsoft Windows, you ask, and the PC does the work. RTX Spark isn't a concept chip sitting in a lab either. NVIDIA has confirmed the first laptops and mini PCs built around it will ship this fall in 2026, with Asus and MSI leading the initial rollout, followed by Acer and Gigabyte shortly after, and additional machines from Dell, HP, Lenovo, and Microsoft's own Surface line arriving later in the year. Wall Street noticed immediately. Shares of AMD, Intel, and Qualcomm all dipped on the day of the announcement as investors recognized NVIDIA was stepping directly into the PC chip market for the first time. That's the setup. In the next section, we're going deeper into exactly how this new class of hardware works, the specific mini PCs already shipping right now that prove this isn't just a future promise, and why the smart home industry is quietly becoming inseparable from the computer sitting in your house. Let's pick up right where we left off, because the hardware I mentioned isn't a future promise sitting in a lab somewhere. Some of it is already on sale, and what's already shipping tells you exactly where this is heading. At Computex 2026, held in Taipei at the start of June, Asus didn't just talk about agentic AI in the abstract. It put real, purchasable hardware on the table. The first is the Ascent GX10, a mini PC small enough to sit next to your router that runs on NVIDIA's GB10 Grace Blackwell superchip, packing 128 gigabytes of unified memory and delivering roughly 1 petaflop of AI compute. To put that in perspective, that's processing power that not long ago would have required a dedicated server room, now sitting in a box you could hold in one hand. Asus positions it directly against machines like the Mac Studio and AMD's Ryzen AI Max Plus desktops, and it won a Best Choice Award at the show. Reviewers and analysts covering the event weren't shy about calling this a preview of what standard home computing hardware is going to look like within the next few years, not a niche product for AI researchers. Right alongside it, Asus also unveiled the Ascent QN10, which it's calling the world's first mini PC built around Qualcomm's new Snapdragon X2 Elite platform. This one's smaller still, under 0.7 liters, weighing about 720 grams, roughly the size of a paperback book. Yet it drives 4 4K displays simultaneously and packs an 18-core Orion CPU, alongside a Hexagon NPU rated at 80 TOPS, meaning 80 trillion AI operations per second. That NPU is specifically built to run agent frameworks and on-device AI tools locally, without sending anything to the cloud. Neither Asus device has a confirmed retail price as of this recording, but industry estimates based on comparable Qualcomm-powered hardware put the QN10 north of $1,000, putting it in direct competition with Apple's entry-level Mac Mini. Now, why does any of this actually matter to you if you're not a developer or an AI researcher? Because both of these machines represent the exact same underlying shift, always on, locally running intelligence that doesn't need a constant cloud connection to function. And that shift connects directly to something bigger happening just outside your computer, inside the rest of your house. For the last decade, the dominant model for computing power has been the cloud. Your device stayed relatively simple and offloaded the heavy processing to massive data centers run by companies like Amazon, Google, and Microsoft. That model was fast enough and cheap. Enough to make sense, but it came with 3 real problems. First, it needed a constant internet connection to function at all. Second, it introduced latency, small delays between asking something and getting an answer, which makes truly responsive, autonomous AI agents impractical. Third, and most importantly for privacy, it meant your personal data had to leave your home and live on someone else's server. Edge computing, processing that happens locally on your own device instead of a remote data center, solves all 3 problems simultaneously. By moving that processing power back into the home, the newest generation of AI hardware can respond in real time, keep working even if your internet drops. And most importantly, never send your personal information anywhere at all. That's not a minor technical tweak. It's a genuine reversal of the cloud-first model that's defined the past 15 years of computing. And the smart home industry is accelerating right alongside it, faster than most people have registered. Recent industry surveys put smart home device adoption in American households at more than half, with the average connected home now containing somewhere between 15 and 20 individual smart devices, up sharply from a fraction of that just a few years ago. That growth curve isn't flattening out, it's accelerating, and it's converging directly with the same AI hardware we just walked through. This is where the language shifts from smart home to something the industry is now calling homes that think. Not the old model, where you tell your thermostat what temperature you want and it obediently complies. The newer generation of home AI systems, built on the exact hardware we just covered, doesn't wait for a command at all. Using local data processing and pattern recognition running entirely on device, these systems increasingly anticipate what you need before you consciously ask for it, learning that you tend to run cold on weekday mornings but not on weekends, adjusting lighting a couple of minutes before you typically walk into the kitchen, or dimming your workspace lighting automatically during video calls that have historically correlated with higher stress. These systems aren't just executing instructions anymore. They're making low-stakes decisions on your behalf, continuously in the background. Underneath all of that sits voice, which is often treated as the flashy front end, but is really just the input layer, the real. Intelligence lives in what's called the inference layer, the part of the system that interprets not just the literal words you said, but what you actually meant, and increasingly what you're likely to need next. That layer is exactly what chips like RTX Spark, the Ascent GX10, and the Ascent QN10 are built to run locally, privately, and continuously. So step back and look at the full picture forming here. The PC market is shrinking in unit volume because of a memory shortage, while simultaneously the actual capability of what a personal computer even means is expanding faster than at any point in decades. Machines that fit on your desk are now running workloads that used to require server rooms, and your house itself, through its lighting, its thermostat, its cameras, its appliances, is quietly becoming an extension of that same computing environment rather than a separate category of gadget entirely. But there's one more layer to this transformation that most coverage either oversimplifies or wildly overhypes, and it deserves a clear-eyed explanation. What's actually happening with quantum computing, spatial computing, and whether the flat screen you're staring at right now has a genuine expiration date? That's exactly where we're headed next. Let's keep building on this, because everything we've covered so far, the shrinking PC market, the local AI chips, the thinking homes, all connects to a bigger visual and computational shift that's about to change how you actually interact with your devices. Let's talk about the screen in front of you right now, because it might have a shorter shelf life than you think. The flat rectangular monitor, the thing you've stared at for essentially every computing task of your life, was never actually the ideal way to interact with a computer. It was simply the best available option for the past 40 years. And in 2026, that era is starting to visibly wind down. Spatial computing is the umbrella term for technology that blends digital information with your physical surroundings in 3 dimensions. Augmented reality overlays digital content onto the real world around you. Virtual reality replaces that world entirely with a digital one. Mixed reality blends both together in real time. What's changed recently is that spatial computing has stopped being a prototype curiosity and started delivering measurable results in fields like healthcare, manufacturing, and education, with consumer entertainment quickly catching up. Industry analysts tracking this space have projected that spatial computing adoption accelerates sharply through 2026, with AR and VR experiences increasingly moving away from pre-scripted content and toward AI-generated, dynamically responsive environments. Non-player characters powered by actual language models with persistent memory and independent behavior, rather than fixed scripts. At Computex 2026, a company called Kineron, which has spent nearly a decade building full-stack edge AI infrastructure, unveiled what it's calling an AI PC companion built around emotionally intelligent computing. According to Kineron's own announcement, the system is designed to process vision, voice, spatial awareness, and contextual understanding entirely on device, without any cloud connection required, and without personal data ever leaving the home. The stated goal, in Kineron's own words, is AI that operates continuously, privately and intuitively, as an early step toward technology that understands you as a human being rather than treating you as a user issuing isolated commands. Asus showcased something similar at the same event, a next-generation companion robot designed to build ongoing familiarity with a household over time, while handling real tasks like drafting messages and organizing schedules, not just holding conversations. That vision might sound abstract. Watching it described in a video today, it's genuinely not going to sound abstract in 3 or 4 years, given how quickly this hardware is already shipping. Now, before we go further, there's one more technology that absolutely has to be part of this conversation, and it requires real precision to discuss, honestly, because the hype around it has created a lot of confusion. Quantum computing. Here's the direct version. You will not have a quantum computer sitting in your home before 2040, and possibly not before 2050. If anyone tells you otherwise, they're either confused or trying to sell you something. Quantum systems currently require cooling to temperatures colder than deep space and extraordinarily precise engineering just to maintain a stable quantum state. A consumer-friendly home quantum computer isn't a near-term roadmap item for any serious company on the planet right now, full stop. But here's what's actually true and actually relevant to you. You don't need to own a quantum computer to benefit from quantum computing. The model looks a lot like the cloud computing model that's defined the last 15 years, just applied to a technology that makes today's cloud AI look basic by comparison. Developers and researchers can already submit computational jobs to real quantum processors over the internet through platforms operated by companies including IBM. The heavy lifting happens inside specialized quantum data centers. Your device simply sends the request and receives the result, the same way you don't think about the server farms running behind a Google search today. Many researchers in the field expect meaningful, industry-specific quantum advantage points, where quantum systems clearly outperform classical computers on real tasks like drug discovery simulation, financial modeling, and material science to start showing up for serious applications before the end of this decade. The quantum layer stays invisible to you as a home user, but the downstream benefits, better diagnostic tools, sharper financial planning software, stronger encryption, protecting your personal data will be real and will show up in products you actually use. What ties this back to your home computer is that the AI PC hardware being built right now is explicitly designed with this split architecture in mind. Your local device, whether that's an RTX Spark laptop or an Ascent-style mini PC, handles the immediate, private, real-time processing at the edge. Remote quantum and cloud systems handle the small category of problems, too complex for any classical device to solve in a reasonable time. Together, that combination creates a computing environment with almost incomprehensible depth, available through nothing more exotic than a normal home internet connection. Now, let's circle back to the practical constraint sitting underneath literally everything we've covered today, the RAM shortage, because it explains why this transformation is arriving unevenly rather than all at once. Training and running large AI models requires enormous amounts of high bandwidth memory, and that demand has grown faster than the global semiconductor supply chain was prepared to absorb. IDC's own reporting ties its revised, sharper PC shipment decline for 2026 directly to this memory crunch, along with rising average selling prices that are expected to persist well into 2027. This creates a genuinely bifurcated market. Premium AI PCs with dedicated neural processing units and ample high bandwidth memory sitting at the top end, while a large chunk of the mid-market effectively stagnates as buyers wait for prices to normalize. A normalization IDC doesn't expect to see fully play out until 2028 at the earliest. This same pressure is reshaping the competitive landscape among chipmakers themselves. Intel has struggled to adapt an architecture built around the old, user-initiated, app-centric model of computing. AMD has moved faster, with its Ryzen AI Max Plus processor line, known as Strix Halo, delivering integrated graphics capable of challenging discrete GPUs on AI inference workloads inside smaller, more energy-efficient machines, and the company has confirmed its own branded mini PC, Ryzen AI Halo, is launching later in 2026 to compete directly with NVIDIA's new hardware. Qualcomm, meanwhile, has brought its Snapdragon X2 Elite architecture, originally built for always-on efficiency in mobile phones, directly into the PC space through devices like the Asus Ascent QN10 we covered earlier. The competitive order of the entire chip industry is being rewritten in real time, and whoever wins that fight will largely determine what your next home computer actually looks and behaves like. So here's where all of this leaves us. Screens are starting to become optional rather than mandatory. Quantum computing is real, but it lives in the cloud, not on your desk, for at least another decade. And the memory shortage constraining today's market isn't a sign this transformation is slowing down. It's a side effect of demand for AI hardware outpacing what the supply chain can currently produce. In the final section, we're pulling all of this together into an actual timeline. What changes by 2027, what changes by 2030, the real obstacles standing in the way, and the honest answer to whether your next computer purchase should factor any of this in at all. Let's bring this home and turn everything we've covered into an actual timeline, because a transformation this big is meaningless without a sense of when it actually reaches you. First, the macro number that frames all of it. Even with the current memory-driven contraction, IDC still expects the broader device market to keep growing in value terms over the medium term, and other industry analysts covering global IT spending, including Gartner, have projected worldwide IT spending growth in the high single digits for 2026, even as device-specific spending growth slows because of the same hardware constraints we just walked through. The point isn't that the industry is shrinking, it's that it's temporarily bottlenecked by physical component supply, while the underlying demand for AI-capable computing keeps climbing. That's a very different story than computers are becoming less important, and it's worth being clear about that distinction because a lot of headlines this year have blurred the two. Remote and hybrid work also isn't reversing. The home has permanently become one of the most important computing environments that exists, not a secondary one. People work from home, learn from home, and increasingly expect their home setup to be as capable as anything sitting in a corporate office. That's part of why compact, AI-accelerated desktops and mini PCs, exactly the category ASUS, NVIDIA and Qualcomm all leaned into at Computex 2026, have become the form factor generating the most consumer interest this year, ahead of both gaming desktops and traditional laptops, in several industry search and interest indices. It's not a coincidence that the most talked about product reveals at this year's show weren't massive gaming rigs or enterprise servers. They were small, unassuming boxes designed to sit quietly in a home office while running AI workloads that used to require corporate-grade infrastructure. So here's a realistic timeline based on what's actually shipping and what credible analysts and manufacturers are projecting, not speculative hype. By 2027, neural processing units are expected to become standard equipment in essentially every new PC above entry-level pricing, following the same trajectory Copilot plus PC requirements have already set in motion. By 2028, expect the first genuinely mass-market wave of agentic home AI systems, tools that manage meaningful chunks of your daily routine with minimal ongoing input from you, arriving in mainstream retail rather than developer previews. By 2030, spatial computing hardware, lighter AR glasses, and more capable, mixed reality devices is expected to cross the price and usability threshold needed for widespread consumer adoption, following the E. Same pattern smartphones followed a decade and a half ago. And somewhere around 2035, sitting down at a traditional desktop, opening a browser and manually clicking through software may start to feel about as old-fashioned as calling a travel agent to book a flight. Feels today. Not gone, not impossible, just increasingly unnecessary for most everyday tasks. None of this is guaranteed to happen frictionlessly, though, and I want to be honest about the real obstacles standing in the way, because a balanced take matters more than a dramatic one. The RAM shortage is real, and based on IDC's own guidance, it's expected to keep affecting pricing and availability well into 2027, with a full return to 2025-era pricing considered unlikely even after supply eases around 2028. Privacy concerns around always-on AI systems are completely legitimate, and they're already driving early regulatory attention, particularly across the European Union, where data protection frameworks tend to move faster than in most other regions. The energy consumption of running powerful NPUs continuously across millions of homes simultaneously is a genuine unsolved problem that the industry hasn't fully cracked yet. And cybersecurity in a world of autonomous home agents is a serious, still developing challenge. An agent with standing access to your email, calendar, finances, smart locks, and shopping accounts is an extremely high-value target for anyone trying to exploit it. The security frameworks to properly defend that surface area are still being built in parallel with the hardware itself, including NVIDIA and Microsoft's own recently announced security primitives designed specifically to sandbox these agents from full, unrestricted access. These friction points are real, and they will absolutely slow the edges of this timeline. What they won't do is stop the overall direction. The economic incentives, the competitive pressure between NVIDIA, AMD, Intel, and Qualcomm, the consumer appetite already showing up in market interest data, and the raw capability of the hardware we've walked through today are all pointing the same way. Hard. The pace might shift by a year or two in either direction, depending on how quickly the memory shortage resolves. The destination isn't really in question anymore. So what does this actually mean for you practically the next time you're shopping for a computer? It means paying attention to NPU, performance and unified memory capacity, not just raw CPU clock speed, the same way people learned to check camera specs and battery life when smartphones went through their own transformation years ago. It means understanding that the machine you buy in 2027 is likely to behave fundamentally differently from the one you're using right now, not just run faster. The computer isn't dying. It's evolving into something that genuinely doesn't have a settled name yet, something that doesn't sit idle waiting for you to open an app, but instead already knows your schedule, your patterns, and your preferences, and quietly works on your behalf in the background. So here's my honest question for you, and I actually want to hear the answer in the comments. Are you excited about a home computer that acts on its own? Or does the idea of an always-on AI agent with access to your calendar, your finances, and your smart home genuinely worry you? Both reactions are completely reasonable, and I think most people watching this are somewhere in between. If this breakdown actually helped you understand where home computing is really headed instead of just adding to the noise, hit the like button, subscribe, if you want the next big tech shift explained with real sources instead of speculation, and I'll see you in the next one.